allow me to introduce a little C library I wrote a couple years ago called Simple JSON. It's my attempt at making a pure C library that can load, save, parse, and work with JSON in a memory-safe way, in spite of the fact that it's in C. I am one of these old school C programmers who's not very fond of JavaScript in general, although credit where it is due, it basically runs the internet. However, I really have to say, of all the config file formats I have worked with over the years, XML, YAML, INIs, etc., JSON is without a doubt my favorite. Even worked with some proprietary ones like id Software's def files. I just really like JSON. It's very versatile. It's easy to read. It's easy to parse. It's minifiable. Overall, I just really like JSON. I had been working with a JSON library that I'm not going to name, maybe circa 2015, when I realized that there was a massive memory leak in the library I was using. So I decided, hey, it couldn't be that hard. Let me go ahead and write my own JSON library. And I've had some success, but over the years I've refined this and turned this into a very clean and stable library. I don't have release candidates for it, but you can download it. It is based on standard ANSI C, so it has no external dependencies other than standard C. It should compile on Windows. I use it all the time on Linux. Should compile on Mac as well, or whatever operating system you're going to target. As long as it can compile C, it should work. My make files I include with it. Oh, let me go take a look at the code. I provide make files with it that will turn it into a static lib on Linux. I don't have prefab project files for Windows, but all you really have to do is just copy all the C files and header files into your project, and it should just work. So let's talk about JSON. If you haven't worked with JSON before, well, let me show you what example of what a JSON file might look like. Let's see if I have any I can showcase. I don't. Yes, I do. I've got plenty of projects that work with JSON. I've got a baseball game that I was working on. And so we can take a look at some field position information. So here's an example of a JSON file. One of the things I like about Kate, by the way, is context highlighting regardless of file name extension. So a little bit introduction to JavaScript. All JavaScript objects files start with the object notation, which is the open brace, as the root of all JSON files. After that, you're going to have key value pairs where you've got a key as some sort of string identifier, colon, and then something else. And so right now I only have just this one in this file. But you can have arrays as well. So open with the square brackets, you can have a number of things. Now, generally, there's no requirement for everything in the array to be uniform, but I find it's a good best practice to just decide what that is going to look like for whatever purposes you're applying. But as with anything, when you're loading from config, you can never trust it. So always check for existence before using whatever you try to pull out of the config file. So here is another object, and you can see it's full of more key value pairs. So strings, numbers, there's even support for more complicated data structures. However you can describe it between arrays, terminal types, and key value pair objects. You can do it with JavaScript object notation, JSON. My JSON library. You only really need to worry about what's in json.h. We have all of the documented files. Now I do want to give you a caveat. I do make my function names verbose. I find it's useful when I'm teaching my classes to have everything spelled out for my students. I do have plans in my GitHub repository, which is here, to provide aliases for all the longer named convention files, make it easier to work with. With autofills being a thing, I don't find it when I'm working on my own projects to be very much of a setback. Anyway, let's start talking about how to work with this project. First thing you're likely to do is work with an existing JavaScript file. So the things we're going to want to work with are, well, we have SJ, which is the simple JSON prefix for this library, SJ load. This is going to give us access to whatever file we're going to do. So we need to declare that this returns a pointer to this simple JSON object type. So just declare something as my JSON equals, sorry, I'm using this in Google Slides because I find it just easy to visualize without having a physical whiteboard in front of you. SJ load, and then whatever the config file path to config file.json or whatever. The file extension is, of course, just a hint to the operating system, and for us, you can name it anything you'd like. It's just a text file. This will return null if it failed, so always check for existence before you do something. So if not JSON, you're going to want to error out why it failed. Errors go here. And then return or fail to continue working on whatever it is you were working on. And then at some point, after you've worked with it, you're going to end up calling SJ free on what you have allocated. So this file load will allocate and build the JSON data structures from the config file. It will then close the file. The file handle is not kept open during the life of the JSON object. It is copied out of it, and then the file is closed. But it does allocate all the information it needs, so make sure that you clean it up when you are done. In order to access stuff, you're going to need to, at the very least, have to go down to my object stuff. So object, SJ object, get value. So let's continue loading JSON. I'll probably make this file available too on the comments. All right, so this returns a JavaScript object. Now, the JavaScript object type is a wrapper. It whether it's an object, a list, or some kind of terminal, it's all a JavaScript object. Or a JSON type. So there's an internal switch that determines what type it is. And I've got some functions that you can test for existence or test for type if you care. If you know what your config file looks like, you can just hope and try. That's the way this would work in action. Going off my previous example here, if we've loaded the JSON into a JSON type, I could then do, sjson star, maybe some kind of array. And then I could do array equals SJ object. I'm going to copy paste. Why type if I don't have to? But I'm going to get it out of the JSON that we loaded, and then I give it the key that I want to access it. The baseball example would be I'd want field positions. And of course, I would make sure if not array, then I would error out here. Provide error message, or whatever it is I'm going to do. Skip it. I based the iteration of the arrays on a glib list. So if you've worked with glib before, the syntax should be remarkably similar. So what I would do is give myself an counting variable and a count, and I would set my count equals SJ array get count. Sorry I didn't bother showing you this in the documentation or in the header file, which in this case is the documentation, but you can array append delete get count. That's the function where we would get it. I would probably shorten this to array count, cutting out 4 whole letters, and that from the array. And then I can do a for loop for I equals 0 while I is less than count, I plus plus, and then in here I would set it to, I need some kind of item. Once again, a pointer We're not dealing with the actual data here. We're getting pointers to the data, which means generally you should probably not mess with what's inside it unless you know what you're doing. I didn't make them constant because I figured there could be a case where you know what you're doing and want to mess with it. So I give the choice to the using programmer. All right, so item equals sjArray get nth. We want to get the nth out of the array, and the I value here is what we want. And then we would check to make sure it actually worked. If not, stop capitalizing. If not item, skip. And then otherwise, do whatever on the item. If I know what's in there, again, if I know I'm getting an array of integers, I can convert the item to the integer with, we have these up here, get the values. So get integer 32 value, unsigned 8-bit value, generic integer values, and these work with passing into a pointer. So I would have my int number. Oh, it's getting tiny and hard to read. Let me format this a bit better. Let's single space this and increase the size anyway. Now I would give it not a pointer to an integer. I have the integer, so I need to provide a pointer to it. So I would provide the address to the number from my item, if that's what my item was, if it was an array of numbers, or if it was another object and I know what I want to get out of it is a number, I could basically combine the process of getting the value as a type down here. So here would be the same thing. Get it as a type. The object I'm getting out of would be the item. The key, well, let's take a look at what my example JSON has here. These are not integers, these are floats. Let's get it as a float. So let's get stamina. And this instead would be as float. And I would need a number to be float. And again, I would get the address of the number. Now, just as a caveat, when you're using these accessors, if it doesn't find it, or if there's something else that has gone wrong, it's going to leave the number unchanged. So the function will return true or false depending on whether or not it was successful. So these are return 0 if not found or not an integer, or 1 if it was successful. So this will not be changed. So make sure you set up your own defaults in case this fails to find what you're looking for, or check, and then error out if you need to. One thing that's different is when I'm getting a string value, it does return it as a constant character pointer, which means do not modify what's in the string that you get back, but it will return null if it failed. So check for null before you access any string. So that's how a string will tell you, a character array, will tell you if it was not found or failed. So remember, always check for existence before you use any standard C string function, because it doesn't, and that will crash. So that's like loading. That's pretty much all you need to do as a quick accessing, pulling data out of things. Now, the other side of the equation would be saving JSON. If I want to write JSON back to a file, I can. Now, there is one feature I haven't implemented yet. So by default and by only, when I write JSON to file, I write it minified. I don't have the pretty formatting that you're probably used to, but you can find any JSON formatting converter online to convert it back to human readable if you need to. I oftentimes will use these as like player save states, so I generally don't need to be modifying it by hand after the fact. But just to be clear though, the code will load minified or pretty formatted, indented JSON. It just only saves in the one format. So let's say I've got some data structure, some hypothetical data structure that will have, say, a char name of 50 characters. That's a terrible length to do, but whatever, it's an example. And then I've got, say, int health. And these are my two things that I'm dealing with in my type here. And at some point I want to save this bit of information to disk. So I'd make my save function. And I need to have a file name where I'd want to save it. Well, I start building, you now build the JSON instead. So the first thing you need to do is have your simple JSON that we're going to build, and this is going to be JSON equals sjnew. Actually, no, it's not true. I lied. It's not sjnew. It's sjObjectNew, because there is no generic JSON. It is, at the very least, going to be an object. So the very root of our file always needs to be an object. So that's what we set it to. Now from here, our root JSON, we can insert into our root JSON our name and our health. So we can do object insert. And the JavaScript, or where object returning it into, is the JSON. The key, I always like to use the same name as my variables just to keep things less error prone. And the value that I'm going to import now needs to be created as well. So my name is a string, so I need to make a new string. So up here I have, I'm probably just missing it. Object new, string new. I think I just didn't organize this well. New string, here we are. Make a new string, which didn't follow the naming convention or everything else. And so I provide this, and then I can provide name, or whatever my type is. Let me give this as some kind of type def struct player. And I had provided maybe a player here as well. And so this would be now player name. And then I would also sj object insert into the JSON, the value health, and now I would need the new integer value. The get integer value, new int. And so this will take an integer and create a appropriate JavaScript type here. And now the integer value I'm providing in this case would be player health. And then at the end of this, we would, return. So let's make this a little bit fancier. Let's make this a JavaScript object notation pointer. Call this player save. Oop, I didn't mean to move that. Return the JSON. And then, nope, we're getting small again. And that somehow made it worse. All right. Let's continue this. Duplicate slide. Continued. And so now, using the previous function that we've defined on the previous slide, we would just save to file. And notice that the previous one no longer needed, this one didn't need the file name because we're not using it here. Player2JSON. And this is player save. And now what we're going to do is same thing, actually. We're going to have a JSON. We're going to make the object new, and then we're going to sj object insert. Now we should probably have like a thing like here where it'll be like star player JSON. And what we'll do is we'll set player JSON equal to our player to JSON function. Oops. Sorry, I'm used to hotkeys of going through the actual code. Pass the player through. If not player JSON, we would return. Actually, this is going to return anything. This one is going to be a void function. You would return void or null, nothing. We're going to return anything. We would then insert. We wouldn't even actually make this unless that worked. And then we insert into the JSON player data, player JSON. Now we can now take this JSON object that we've now built, and we can do sj save. Now let's see, remind myself what that looks like. The JSON and the file name, which is JSON and the file name. At this point, it would be saved to disk with whatever we saved, but now we have allocated all this JSON information. We need to clean it up. We no longer need it. sj free the JSON. And that's how we would create a save type, or at least any kind of thing you'd want to save with JSON. I'm talking from a game development perspective. That's the whole point of my channel, is game development, but there's no reason this can't be applied anywhere else as well. A couple things to go about with cleanup. So I just talked about sj free. This function is, will clean up anything from the root of the JSON down to any kind of nested data that may have been allocated for it. It's important to keep track of, if I have, say, different functions that are going to parse out different bits of information, to not clean up anything that you don't own. So if I were to load something, the thing that loaded it should free it, not if I, say, had the reverse of this. If I had a player load function, it would pull the information out of the JSON, and maybe I had like an inventory which would be parsed out of that. The inventory should not free the JSON. It doesn't own it. The person that loaded it owns it. You may decide you want to have an extra copy of it in memory, like, hey, I'm going to parse some of this stuff out of memory and then free it up, but part of it I want to keep around for whatever purposes. You can copy. So I've got this sj copy, which returns a duplicated bit of the JSON that's provided. The copy must be freed. So normally when I'm pulling things out of the JSON, I'm searching with objects or arrays, you should leave it alone and let the owner free it up. But if I make a copy, now I'm a new owner and I must free my copy when I am done. So as I always tell my students, with C, there is great power, and with that great power comes great responsibility. So you must always get used to being a good steward of the memory that you have access to. Whatever you load, you close. Whatever you allocate, you free. Whatever you create, you destroy. So whenever you're creating something new, in this case you'd be creating something new, or in this case you'd be creating something new, you clean it up to make sure that you're a good steward of the memory that you're being entrusted to. The best part and the worst part of C all in one. A couple other notes. Java, my JSON library is not optimized, which means when I'm doing with JavaScript object and I'm doing a key value pair, I am not searching with a hash map, which would be an O of 1 search. I am searching linearly, which means an O of n search. Now, if I only have 11 or so things to search, that's no big deal. But if I have a very large data set, then you're probably going to not want to deal with it with JSON. Load it up as JSON and then parse it out into something better. Use a hash map. In fact, if you've seen in my other videos on my game framework core, I have a hash map data structure you can use, again, based on the glib one, but significantly less powerful. I'm not deluded as to what it can do. But keep in mind, particularly if you're working with games, do not parse JSON in a main critical loop anywhere. If you can parse this stuff out, cache it, convert it into a more rigid data structure that can be more quickly accessed, do so. If it's a one-off that happens infrequently, then just deal with it. If parsing the JavaScript is probably not as intensive as file ops, as long as you're not dealing with very, very large numbers. So use it as your discretion. I hope this is going to be helpful. Plenty of examples of its use in my GFC and my Game Framework 2D and Game Framework 3D projects. It's just, I find it very useful. It's probably the cleanest library I've written. So have fun with it if you feel free. It is MIT licensed, so even feel free to extend it further if you'd like. Just remember to drop a line of credit with whatever you do. All right. Thank you for your time. Take care.